All right, so let's take some example about how to use character and string arrays. So as you know, character arrays are used to store characters data, but we can create two-dimensional character arrays only if the number of elements in the row are the same. So let's take this example in here. Okay, let me copy this, put it in here. All right, so I'm trying to create a matrix which has like how many rows? 1, 2, 3, 4, 5 rows. All right, so as you know, each row has like different number of elements because the names in here are not the same size. So this, for example, 7. This is 1, 2, 3, 4, 5, 6. This is 1, 2, 3, 4, 5, and so on and so forth. So this will not work because as you know, for matrix, the number of columns in each row has to be equal. So when I run this, it will give me an error. Let's try it out. So as you see in here, it gave you an error. So because the dimension of the arrays being concatenated are not consistent. So there's two alternative ways to do it. The first way is by using the car function. Let's copy this in here. Okay, let's do the car function. So car, and then and here's a single quote Stephen, and there's comma, not semicolon, comma. Remember this, and you have the second name, the third name, the fourth name, and the fifth name. This will work. Why? Because the car function pads means adds a character array with spaces so that every row has the same number of elements. So the maximum one is 7, so it will make all of them 7s. But what does it do? It pads each one with the spaces that to be equal. Just remember that a space is a character. Space is a character. A is a character. Capital A is a character. Alright, so remember that. So let's try it out. Here you go. So in here, it created 5 by 7, 5 rows. 1, 2, 3, 4, 5 by 7. And you see in here it padded one space. In here it padded one space. In here it padded 2 spaces. In here no padding because this is the most long one, the longest one. All right, and this padded in here like 2 spaces. So that we were able to do that. Now this makes sense, right? Uh, uh, the so the third way of doing is by using the string function. So let's name here, okay, n, create n. All right, so n, and we use the string function. All right, and in the string function, as we learned before, we have to put it through in between 2 braces, and then we put the rows in here, and each one separated by a semicolon. Again, semicolon, not a colon here. Let's try it out. Here you go. So in here what we have, 5 by 1 string arrays. So string, this is a string, 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 string. So we have 5 by 1 a string, and look at the icon in here, it says a string. In here it's a character. So this is like 5 rows of 7 columns of characters. So completely different. The advantage of using this way, that it will save you a lot of space. Only 70 bytes are used because we use like 2 bytes per character. In a string it will be much more bigger, as you see in here, but it's working. All right, so let's say that we are trying to create another matrix for, let's say, grades. Let's say for grades. So you have in here for the 5 people, you have grades 84, 100, 88, 95, and 100. All right, and so you have 5, 5. So P is the grades. Now, if I need to link or connect the names to the grades, um, uh, what we did before, okay, what we did before is simply we use the results, like in here. This is the results, all right, the results. Okay, copy. Let me copy, put it in here. So the M, which is the names, I created the M here in the previous one, the M there, and P, which is the grades. Do you think it will work? Okay, so before you answer, the question is M is characters, P are numbers, numeric numbers. So what we have learned before, that when we have character with the numeric will be converted to character to the equivalent ASCII code. Alright, so let's take a look what will happen here. Oh, that's really funny. So Stephen and T, where T came from? T is the ASCII code for the 84. And if you don't believe me, go to the chart that we have seen before and let's look for the 84. Where is 84? Here is T. 84 is T. As you see it in here, 84 is T. 100, it was changed to what? To D. Why? Let's go back to the chart again. Where's 100? 100, 100, 100. It's D. So what happened there, it was converted to the ASCII code, and that's not the result we wanted. So we have learned when you have character with a numeric, the numeric will be converted to the equivalent ASCII code. Alright? So there is a great function that we could use that could convert the P to string. So let's save it in a queue. So let's copy this, copy, and in here, all right. So Control V. All right. So what happened in here? We took the P matrix and we converted the numeric to string, and we saved it in another matrix called a Q. Now, what is a Q? Q is another matrix which is 5 times 3. Because in here we have only 2, it put space, reserve the space. 100, space 88, space 95, space 100. Alright? Now, if I go and run this one in here, okay, if I'm trying to join them together, worked. Why? Because M is a matrix of characters and Q is a matrix of characters. So it gave you a wonderful result as you see it in here. Also, you could use a display. You could use a display in here. So when you do display, the same thing, display it wonderfully. So that's the information I wanted, and it looks perfect. It looks very, very, very good, right? Right. So that's what it is. Okay, you could also, if you need to be like a progressive, you could use the code. If you don't want to convert the P to string to character, you could use this program, the for loop. Look in here. So so you loop through the B. So from K to the length of the B. What is the length of the P? Is 5. So you're gonna loop 5 times, and then you do use if print. So I reserve 10 spaces. I put aside 10 spaces for a string, and I'm gonna read it from M, which has the names. All right. So this will go the row 1, all the characters, row 2, all the characters, row 3, all the characters, row 4, all the characters, and row 5, all the characters. And also, I reserve 8 spaces, float, okay, float, and I'm gonna read it from the K. So if I don't want to do the function and the conversion, I could use the for loop as you see it in here. Let me clear it in here. Let me put this in here, and let me run it. Here you go. All right. So I mean, there's multiple solutions that you could use. There's multiple solutions that you could use, and they are all available for you to use as you wish. Also, you could use the string. Remember, we generated the string with the n in here. Let's do it again for you in here, the n using a string. So maybe that will be much more easier. CLC, and let me do the n. So in here I'm using the string function to generate. So in here what I have 5 times one string, 5 rows, and each row has one string. All right. So now easily I could use the n with the b. There is no issue. There is no issue will be, I think. So here you go. So as you see in here, you have you combined we combined the 5 times 1 string array, the n, and the score were stored in a numeric array called p. All right, so it worked perfectly. All right. Also, we could use a print f like this. You could print it from the r. Okay, remember that the r. So here's the r. The r at least it reads column by column. Okay, so print print f, and then I reserve 10 spaces for a string. Okay, and then another 10 spaces for another string, because we have string and string. All right, and you're gonna read it from r. You're gonna read it from r. You're gonna read it from r. So let's run it, see where is the problem. There's a small problem with this, so let's run it. Okay, all right, where is the problem? The problem is that this is when it reads it like it reads it column by column. So in here um, um, r is what? R is 3 by 2, so it reads um, uh, 3 by 2 is the 3. Okay, it reads Stephen, then Megan, put it in here, then David, put it in there, then Michael, put it there, then this person, then the numbers. So you have to use the transpose. Okay, it reads like this, it reads here like this, like that. So you need to have R transpose. So if you do R transpose like this, all right, so it will read the first name first, put it in the first space area, and reads the next ones, put in the second space area. So that's what I did in here. You see, I did transpose in here, as you see, and this will give you a perfect result that you would like to see. So as you see in here, when I transpose the R, so Steve 84, Megan 100, David 88, Michael 95, and Haiti is 100. So it worked just perfect as it should be. All right. So this shows you that that you could, I mean, how to combine numeric with characters, how to create the character arrays when they have different sizes, and how to use a string. So different talents that you could use, and it will depend on the code you're writing and the logic you would like to use to achieve the goal of the program you're writing. So it's good to have all of these talents handy.